Hello there, Mr. Sutton here, bringing you the AB Calculus 4-3 homework solutions on local extrema. For this problem, we want to know at what x values this function has a relative maximum. So for that, we're going to take the derivative and do some sign analysis to see where we're going from positive f prime to negative f prime. So we've got, let's see, for f prime, this is going to be 15x to the fourth minus 15x squared. And that last 15 is just gone. So we need to set this equal to 0 and solve for critical values. I can take out a 15x squared from all of this. That leaves me with an x squared minus 1 inside. And I see then that this is going to be a true equation when x equals 0 for this x squared out here, and also plus or minus 1 for this x squared minus 1. So that gives me three critical values to put on a number line. Here's my f prime line. So I've got negative 1, 0, and 1, and let me test out something from each of these four intervals. So over here, let me try out negative 2. Now this 15x squared is always going to come out positive, so it's really just down to the x squared minus 1 piece of this. If I plug negative 2 into that, that's going to come out positive. And now a number between negative 1 and 0, we'll go with negative 1/2. Plugging negative 1/2 in, squaring that gives me something that's less than 1, so subtracting 1 is going to give me a negative. And if I plug in positive 1/2, I get the same exact result in here, so another negative. Finally, something bigger than 1, like 2. 2 squared minus 1 is positive. So looking at my sign chart here, I see that I'm changing my f prime from positive to negative at x equals negative 1. Therefore, f has a relative max at x equals negative 1, which is going to give us answer choice A. And if you just take a quick look, there's nowhere else where f prime is changing positive to negative, so none of these answer choices with multiple critical values would have worked here. For this problem, we have a polynomial that has a relative max at negative 2, 4, a min at 1, 1, and another max at 5, 7, no other critical points. How many zeros does this polynomial have? So this is much easier if you just graph it out. I'm going to get an xy axis here, and I'm just going to kind of ballpark where these things are. So negative 2, 4, that's somewhere over here. 1, 1, that's somewhere to the right of the y-axis and above the x-axis. And 5, 7, that's somewhere to the right and above that 1, 1 point. Now, in terms of what this function's doing, since this first one we're told is a relative max, that means our function is going from increasing to decreasing around that one. And this next one, the relative min, we're going from decreasing to increasing. And then finally, this next one's a max, so increasing to decreasing. So just drawing out one possible curve, in order to be increasing before we get to this point, that means our curve has to start below the x-axis and then go up like so. And then we have to go down here, back up here. And then if we're decreasing, we just got to keep decreasing. You don't get to stop. Now this is the only way you could really do this graph because they told you there's no other critical points. So that's telling us there's nowhere else this graph could possibly turn around. Can't turn around over here or here or here or here. So taking a look now at what we have 2 zeros on this graph. We can only cross the x-axis twice, so 2 zeros. So that gives us choice B. For this problem, we're asking if we have 1 plus x to the 2/3, which of the following is not true? Now this is the kind of question where if you knew what x to the 2/3 looked like, it actually looks kind of like a seagull function. It has a cusp in it. If you knew this, then you could immediately eliminate from being true this choice D here that says f prime exists for all x. It doesn't, not at the cusp. But if you didn't know that, we could go through and analyze everything here. And it's worth analyzing anyway, just to get the practice. So we've got f continuous for all real numbers. Is that true or not true? Well, this function is defined everywhere. I mean, you're just cube rooting things. So cube root can take any kind of number, positive, negative, or 0. And you're just squaring it after that. So this is defined everywhere. And there's no jumps in this. It's not a piecewise function, so you can't have any other kind of jumps messing up continuity. And those are really the only two ways to mess up continuity, with jumps and with domain issues. So since there's no jumps and it's defined everywhere, we can say that this is most likely a continuous function. So this is a true statement. Okay, so for this next one, f has a minimum at x equals 0, and then they're talking about increasing, existing, f double prime be negative. So for all of this, we're going to have to figure out what f prime is doing. That'll help us talk about minimums and increasing and all the rest of it. So f prime, that's going to be, let's see, this 1 gets differentiated away. We've got 2/3 x to the negative 1/3. And I'm going to just rewrite that as 2/3 times the cube root of x. A little bit easier to do my analysis with. So if I'm looking for minimums, I need to find critical values. So I'll try setting this equal to 0. The problem is, since my numerator has no variables in it, there's no way to make this fraction 0. So we're not going to get any critical values out of this thing equaling 0. So then we move on to, where's this thing undefined? This is going to be undefined when x is 0, because that'll zero out my denominator. So we're undefined at 0. And again, this would help you very quickly choose choice D. F prime exists is clearly not true because we just found a place where it isn't. But moving on and doing our sign analysis now, we've got the critical value 0, and this is f prime that we're analyzing. And if I take something to the left of that, like -1, and plug it in here, well, that's going to make this negative down here, and we have a positive upstairs, so negative overall. Let me take something to the right, like +1. Plugging that in, I get a positive. And we see that we are going from, f prime is going from negative to positive. So that means that, yes, we do have a min at f equals, f of x, x equals 0 for the f function. So that's true. All right, moving on to the next one. F is increasing for x greater than 0. Well, we did our sign chart here, and to the right of 0, we do have a positive f prime. Since f prime is positive to the right of 0, that means the f function is increasing for those x values. So this is also a true statement. We just saw that f prime exists is not true. It's dne at x equals 0, so that's false. That's going to be the answer choice we pick. But this last one, if you really wanted to know about f double prime, we could find f double prime. That's going to be, let's see here, using our power rule, -2/9 x to the -4/3. And if I rewrite that, this is really -2/9 times the cube root of x to the 4th. So that's kind of crazy. Now, they're saying that this is negative to the right of 0. Well, if you take a look at what's going on here, you've got this number that whatever you're plugging in is being raised to the 4th power. So that automatically makes it positive. Cube rooting that keeps it positive. 9 is a positive. So you're guaranteed to get a positive denominator here, but you've got a negative overall fraction. So this can't help but be negative for all x values. And because x greater than 0 is included in all x values, we can say yes, this is also a true statement as far as it goes. So then at the end of the day, choice D. On this problem, they're telling us that the derivative of f is this x to the 4th and all the rest of it term here. At how many points will the graph of f have a relative max? Now, you have to be careful here because they're giving you the derivative already. Normally, when we look for relative maxes, we take a derivative and do sign analysis, but this is the thing you're going to do sign analysis on. So let's just set this equal to 0, get our critical values, and get to it. So this is going to equal 0 at x equals 0 for this x to the 4th, and then 2 for that x minus 2, and then -3. So setting up a sign chart here, this is an f prime line, you could say. We've got -3, 0, and 2. And now let's just test out our critical values up here. So we've got, let's see, something to the left of -3. Let's go with -4. Now this x to the 4th is always going to come out positive because it's an even exponent. So it's really just these two parentheses that are going to decide the sign of the whole thing. Plugging in -4, that's a negative times a negative, so positive. Plugging in something between -3 and 0, like -1, that's going to be a negative and a positive, so negative overall. Something between 0 and 2, how about +1? That's a negative and a positive, so still comes out to a negative. And then bigger than 2, we've got 3. That's a positive, positive comes out positive. So taking a look at what f prime is doing sign-wise, we see that it is changing from positive to negative at -3 only. Now they were asking at how many points will we have a relative max. Well, you have to go from positive to negative f prime to get one of those. So since we're only doing that at this one spot, we only have one relative max, which is going to give us choice B. For this problem, we're given f prime, the derivative of f, on the interval from -1 to 9, and we want to know on this interval at what value of x does f, the original function, get a relative maximum. So we're basically asking, where does f prime change from positive to negative? And this is a graphing calculator problem, so the fastest way to do this would just be to graph f prime on Desmos and see where we're crossing the x-axis in that direction. So we can see if we do that, that f prime is going to change from positive to negative where? Well, let's pull up Desmos. Here it is. Let me put my f prime into here. Now I'm going to use a different name. I'm going to call it g because f prime doesn't work so well if you start with that in Desmos. And let me make a fraction. Upstairs we've got x cubed minus 8x squared plus 3. And downstairs we've got the square root of x cubed plus 1. So sqrt gives me a square root. And then x to the third power plus 1. And we see a piece of the graph here. Now they wanted this on the interval from -1 to 9. So let me change my window to focus in on that. For my x's, let me actually go from -2 to 10, a little bit more than the interval that they're asking for. And here's what we're looking at. So we want to know where this goes from positive to negative. If I click on the function, and then I can click on the gray dots that I need here, we're going positive to negative right at this spot right about here. That's 0.638. And that is the only spot on this whole interval where we're going positive to negative. So here's that picture that I just came up with on Desmos. We see that this change happens at 0.638. So we can conclude that f has a relative maximum at 0.638, and that's the only place. So that would be choice C. On this problem, they want to know at what x value this function has a relative max. So we need to know where f prime is changing from positive to negative. Let's go ahead and find f prime. That's going to be 15x to the fourth minus 12x squared minus 3. And we need to know where this thing equals 0. So let's see here. I can take out a 3 to start this off. That would leave me with 5x to the fourth minus 4x squared minus 1. And the factoring on this is a little bit spicy, but we can do it. So we know that we're going to need x squareds instead of x's to factor this thing. So I'm going to have a 3 parentheses, and in terms of getting 5x to the fourth, that means I must be doing 5x squared times an x squared. So we have a 5x squared, we have another x squared over here, and now let me just figure out what goes in the rest of these parentheses. Now here's why they felt justified giving you this kind of problem. We've got 1 here. There's only a few things that multiply to give us -1. We could do -1, +1, or +1, -1. If we want to get a -4 as a result, we should probably put the -1 over here so it gets multiplied by the +5. So I'm going to write +1 and -1. 5x squared times this -1 gives us -5x squared. We have 1x squared getting added to that. That gives us the -4x squared in the middle. Factoring has been done. Okay, now we need to find our critical values after all that. So taking a look at each of these, if 5x squared plus 1 equals 0, well, you'd be subtracting 1, dividing by 5, square rooting it. You'd be square rooting a negative number in this case. So that's not actually going to give you anything useful. So 5x squared plus 1, just to write it down, can never equal 0. And then let's see here, this x squared minus 1, that's going to equal 0 at plus or minus 1 if we add 1 and square root both sides. So this actually just gives us 2 critical values to work with, which isn't so bad. Let's put them on our f prime line here, -1, +1. Test out a few things. Let's test out something to the left of -1, like -2. Now, looking back at my derivative, I'm going to use this factored version here. 5x squared is always, plus 1 is always going to come out positive. So really, it's just down to this x squared minus 1 that determines whether the whole thing comes out positive or negative. So if I plug -2 in here, that's essentially 4 minus 1, which is a positive. If I plug in 0 now, that's going to be 0 minus 1, which is negative. Plug in +2, again 4 minus 1 is positive. And we see that we're changing from positive to negative f prime at x equals negative 1. Therefore, f itself has a relative max at x equals negative 1. So that would be choice A. For this problem, we're given a graph of f prime, the derivative of f, and we want to know which describes all the relative extrema of f on the interval from a to b. So we have all sorts of combinations of different numbers of maxes and mins, relative maxes and mins. To get to the bottom of this, we just need to see where f prime is crossing the x-axis and whether it's going negative to positive or positive to negative. Taking a look here, we see that f prime changes negative to positive in two spots, right here and over here. That means that f is going to be having a relative min at those two spots, so that's two relative mins. We also see that f prime changes positive to negative just once, right here. So that gives us one relative max for our f function. So two mins, one max, that is going to be choice A. For this problem, we're given this 9x to the 2/3 plus 3x minus 6 function. We want to know where it has a relative min, at what x value. So we're going to have to do f prime and find out where that changes from negative to positive on this. That's our strategy. So f prime, that's going to be, let's see, derivative, we've got 2/3 times 9, that's 6, x to the negative 1/3. And then 3x is going to be a 3 for its derivative. The minus 6 is gone. So let's go ahead and let's clean this up a little bit, actually. We've got, this is really 6 over the cube root of x. And normally I wouldn't bother turning it back into this, but I've always found that if you merge things together into one big fraction, it's easier to do this whole critical value dance. So merging this into one fraction, this is going to be 6 plus 3 cube root of x, all over cube root of x. So I gave 3 basically a common denominator of a cube root of x. So this is what I'm working with here. Now I want to figure out where this is either 0 or undefined. So for seeing where this thing equals 0, let me do that down here. To figure this out, I can subtract 6 and divide by 3. That'll give me a negative 2 over there. And if the cube root of x equals negative 2, I can cube both sides to get x. So x then must be negative 8. Looking back at our f prime up here, we see that this is actually going to be undefined, dne, at x equals 0 because of that denominator. So that actually ends up giving us not one, but two critical values to be aware of. Let's go ahead and plot those out now. So f prime number line time, we've got negative 8 and 0. And let me test out something to the left of negative 8. Now I'm going to pick an easy number since I don't have a calculator to use. I'm going to pick negative 27. And I say easy just because I'm cube rooting numbers. So that's about as easy as it gets to cube root. 8's also a cube root, but I need something to the left of 8. So plugging that in, this is going to give me a negative in the denominator. Upstairs, we've got 3 times the cube root of negative 27. That would end up being negative 9, which would make the whole numerator negative. Negative over a negative is a positive. Now let's test out something between these two numbers. Negative 1 is a real easy number, and it's also a perfect cube, so that's a bonus. So downstairs we have a negative. Upstairs, this is 3 times negative 1 essentially. Adding that to 6 gives us a positive. Positive over a negative is a negative. And finally, let's test out positive 1 here. So that's going to be a positive downstairs, positive upstairs, overall positive. Now we see that f prime is changing from negative to positive at x equals 0. Therefore, we have f has a relative min at x equals 0, which means answer choice E. For this problem, we're told that f is a function whose derivative is this crazy f prime ln function, and they want to know on the open interval from negative 4 to 1, where does f have a relative max, at what x value? So we're basically trying to figure out where f prime is changing from positive to negative. And since this is a calculator problem, we're just going to plug this into the calculator, into Desmos, and see where we're crossing the x-axis from above to below. So here's Desmos. Let me move that so I can see my function. I'm going to call my derivative g just so I'm not having to use prime right off the bat. And we're going to have ln, parentheses, x to the 4th plus 5x cubed plus x squared minus 7x plus 28. So let me change my window to be from -4 to 1. Go to the wrench here, and let me just make my x values, we'll make it like -4.5 to 1.5. So here's the relevant piece of the graph. So between -4 and 1, if I click on my function and click on the gray dots, we're changing from positive to negative right at this dot here, positive to negative. So that's about, if I take a look at what I've got here, about -3.623. Since we're changing positive to negative there with f prime, that means f has a relative max at that spot. Since that's the only place where we're changing positive to negative on this interval, that means that a, that number only, is going to be our answer.